the development of 4.5 catched up. The main development phase and the merge window ended 11 days ago. So thanks to that, I can already it's already possible to see which features the next kernel version brings. And actually, you can quite predict when this kernel will come out. It's likely the March 14th when Linux 4.5 will come out. So what's new in those kernels? Linux 4.4 brought enhancement for a driver that's called VirtIO GPU. And that enhancements make something possible that's called virtual 3D. Basically, it's you can use GPU acceleration, so 3D acceleration in a VM. But before you conclude, you can use Windows with 3D in your VM now. That is not possible. It's just for Linux guests. So if you're running GNOME 3 or another and compositing desktop modern in your VMs, you in the future will be able to get GPU acceleration in them, and everything, the graphics interface might be a bit quicker thanks to that. Actually, it's not only in the kernel what's needed for that. You also need a new QEMU version and the latest Mesa. And there are there's a lot of fine-tuning still needed. I guess the next Fedora release might be able to, you might be able to use the feature there. But there are a few other things forthcoming to make it even easier to use, and so that might take a little bit longer until it's simply usable without fiddling in your system. What else? 4.4 brought a new graphics driver that's called VC4. That's actually a graphics driver for the different Raspberry Pis. You might ask, hey, why do I need a new graphics driver for that? There are already drivers for that. The thing with this driver is he does most of the things on its own. The drivers you used to use in the past or currently on the Raspberry Pi basically hands a lot of things over to a proprietary driver in the firmware. And that makes a lot of things harder and unflexible sometimes. And the new driver is like a real Linux driver. It doesn't support 3D acceleration yet, but we get back to that later. For the sysadmins amongst you, what Linux 4.4 brought was a locked support for MD RAID 5 and 6. That's something you can use to prevent RAID corruption when the system crashes while writing a new stripe. It's actually a bit similar to what's used in file system. You write something that's called journal. You write out what you're planning to write, and then you actually write it out for real. And if the system crashes in between, you can do the transaction from the log or get back to the old stuff. You actually need a separate drive for that, so even more drives for your big RAID setup. But if you're caring about data integrity, that's important because it fixes the right hole where the RAID might get disturbed if you don't do that. What else? There were some improvements to the TCP stack and the locking. What the developer wrote is 2 years ago you were it was possible to do like about 20,000 synths per second, so the part of the handshake you do when two systems connect. And thanks to the new improvements over the past few years and what got into Linux 4.4 and with the proper software, and if you use everything that's possible, it's now possible to do 6 million synths per second. So quite an achievement over the past few years. And that actually doesn't only make things faster, it makes distributed denial of service attacks also harder because you need way more systems to bring a certain server down. That were some of the most important features from Linux 4.4. If you want to know more details, you find them in the net. Kernel Leemhuis has a good overview, LWN, and the German stuff on heise.de for those that speak German. So, what's coming for 4.4, 4.5. There actually comes the Raspberry Pi driver again. That's getting 3D support in 4.5. So everything needed to do 3D. The actually 3D driver is not part of the kernel. That's, as always, part of Mesa. And that's also, that driver is also in the latest Mesa release already. So basically you have now a real open source graphic driver stack for the Raspberry Pi. But it still needs some fine tuning. So if you just want to use it, you might be better off to simply use what the driver stack that most of the Raspberry Pis use these days. But in the future, these drivers are likely to make a few things better and more flexible. For the gamers out here, there's PowerPlay support coming for a driver that's called AMD GPU. This driver supports a lot of recent and current AMD Radeon drives. And this PowerPlay support makes reclocking and power management possible on those cards. And precisely that's here a few Radeon cards that benefit from that. Those cards in the past simply used a standard base frequency and couldn't switch to their quickest or most power efficient settings because there was no reclocking. So thanks to the PowerPlay support, we can now switch to the fastest mode and get more 3D performance, or switch to lower modes, and the power consumption is not that bad anymore. Yeah, actually improves graphics performance, yeah, but it's disabled for now. So if you want to use it, you have to enable it in your kernel config. It's, as far as I know, enabled in the Fedora Rawhide config and in my own kernels also. But that's not enough. You also need to boot the kernel with a special parameter that's mentioned here. That will change over time. Then it will get enabled automatically, so you don't have to care anymore. It will simply work. That's actually the plan. Maybe that even happens for 4.5. That remains to be seen. Another new feature in 4.5 is something coming from Android. That's a sock destroy function that makes it possible for the admin or network managing software like the network manager to terminate open TCP connections. If you want to do that, the idea behind that, if you leave your house with your notebook or your smartphone and you get out of the reach from your wireless LAN and switch to mobile data networks, streaming doesn't work, stops working normally, because the TCP timeout time is typically 1 or 2 minutes. So until the application that's displaying your stream notices that the TCP connection that was used until you left your house isn't available anymore, the buffer is already empty and you get a black screen. And now the network manager can tell all applications, hey, this connection closed, and they can re-establish a different connection. And together with a big enough buffer, they can. There's no interruption in your stream. A bit low level, but maybe some of you might be interested in. There's a new Seegroup interface. It's called Seegroup version 2. And that actually is a basically revamped control groups feature. The old Seegroups feature that is used to limit how many CPU time or network bandwidth or storage I/O you can use, so resource control. It had a lot of problems. You don't notice if you're running it, just using it via KVM or on your system. But if you're programming it, there are a lot of things where everything is not that good, and that's fixed by the Seegroup 2 interface. Systemd will support it, so most of you will likely not notice that. Things will simply happen in the background, but a lot of things should get better there on that level. For the embedded developers around here, what's also it might be interesting that the ARM multi-platform support with 4.5 gets mostly finished. That's a feature to allow what's normal in the x86 world is like you compile one kernel image and boot it on a lot of different systems that wasn't used to be possible in the ARM world. And thanks to the multi-platform efforts, that's possible these days. So you can compile your kernel for a Raspberry Pi or Banana Pi and a few other platforms, and really use that kernel everywhere. It's not perfect yet. There are still platforms where it doesn't work, but this effort that took 5 years is now mainly finished. All the important platforms were converted some time already, and now with 4.5, even the minor and older platforms get multi-platform enabled. That was part 1, and now I need to get some oil for my voice. Is there a question? I have 3 scars here. Maybe one question between each part.
I'm wondering, did it improve the performance on the Raspberry Pi?
If the new driver improves the performance, actually the driver is so new, I guess for now it doesn't improve the performance, but in the end, that's the plan, yeah. Okay, then this is, yes. So remember, when we get to the end of part 2, you get a scar. So next up, part 2, the important changes in the past 12 to 18 months. One of them is the EBPF, so a 4-letter acronym instead of a 3-letter acronym this time. It's an extended Berkeley package filter, so you might wonder what is that. That is actually what you might know is the Berkeley package filter. And that's what TCP dump uses when you capture frames from your network. Then it actually creates a small program that tells the kernel, hey, I'm only interested in these type of network communication, and then the kernel only hands those packages back to TCP dump. That prevents quite a lot of overhead and makes some analysis only possible, because otherwise there would be so much data it would slow everything down. And in the past 2 or 3 years, BPPF was extended to be a simple, flexible VM. VM in this case actually means abstract computing machine like the Java VM, not a virtual machine like KVM or Zen or VMware are able to set up. And you can use this abstract computing machine to make some things more flexible and improve their performance. And that allows a few new things. And for example, the network traffic control with TC, for example, improved thanks to that. The performance monitoring actually use it for some filtering already, because during performance monitoring there are so many events, what's happening on the CPU. It's important to let the kernel filter what you're interested in and only hand back that to user space. Otherwise there would be so much data, it would really slow everything down. And actually that might in the end finally make some of the dtrace features available on Linux, like easy performance tracing and performance monitoring for your apps. So what else changed? There's a feature that UEFI ERSRT. That's actually a feature where your distribution can put updated firmware somewhere, save it in the firmware itself, and then during the next boot, it's automatically updated. And that actually makes firmware updates as simple as updating every other software. That's actually supported in Fedora 23 already, but the feature also needs to be implemented in the hardware, and the first systems that use this feature are getting out now. Remains to be seen if that's something all of us will be using in 2 or 3 years to update our firmware in our notebooks, servers, or wherever. Another feature that emerged over the past few months was user fault FD. That's a feature which is used by QEMU, where you can simply live migrate a machine over to a different host, and without copying all the memory over immediately, So thanks to that, if the machine was transferred to the new host, it can and needs some memory that wasn't transferred already, and can simply ask the old host, hey, I need this memory now, can you give it to me? And that kind of sounds like it's a bit strange, but actually makes live migration possible in situations where the memory changes a lot, because otherwise it wasn't possible to do live migration without a long disturbance, and because the old machine, the memory changed so quickly that you couldn't transfer it to the new host in the past. There actually was a talk about that on FOSDEM last Sunday. I guess the video recording is online and on YouTube by now, but I haven't checked. What else changed over the past few years? The Radeon driver improved quite a lot. That's just like the AMD GPU driver I mentioned earlier, a driver for lots of AMD Radeon cards, but for a few older generations. So not only the latest generations, but also those that got sold like 2 years ago, and even some up-to-date cards, current models are supported by this driver. This driver improved quite a lot. So 3D performance in this open source driver is now not up to par with the proprietary AMD driver, but it's getting closer and closer. And feature-wise, it really gets closer, because video acceleration for decoding and encoding works. Power management also got a lot of better. Doing audio over HDMI or DisplayPort improved. It's not perfect. Not all of that works perfectly, but the open source driver for the Radeon cards really gets to a point where that's the driver you want, and you don't want the proprietary driver, because it doesn't give you it isn't better, and actually in some parts it's even worse now already. That's not only thanks to the kernel, that's also thanks to the userland drivers in Mesa or LLVM. So that were features that happened over the past few months. Now we are zooming back a little bit, and one of them, getting to a meta layer, new versions of the kernel these days really come every 9 weeks. That's you can nearly bet on that. Sometimes it's 1 week less, sometimes it's 1 or 2 weeks more. But thanks to this development pace, you can quickly see when the next kernel comes and know when features will arrive if they got merged. Another meta thing is there's a new long-term kernel will now get chosen every January. As I said earlier, the 4.4 kernel released this January is a long-term kernel that will be supported for 2 years. And the kernel that will be up to date next year in January, that will then get chosen to be a long-term kernel. So that's easier for those that run your own kernels to prepare, because you know, hey, this kernel in January, that will be one that gets 2 years of support. Another thing is that it seems like there are 1 or 2 security problems in the kernel these days, because a lot of people look for security problems there, and so 1 or 2 come up every week. And among them, like a few times per year, there are really important ones where you really should update your kernel within a few days if you really want to be secure, or better, as quick as possible. And so better be prepared for that security bugs in the kernel will happen, and you have to change now and then and keep an eye on it. What also changed is more and more tools are used to find bugs or things or code where bugs could happen. For example, there are fuzzing tools that are now being used. Trinity is a tool that's used for 3 or 4 years now and then to find code that is not where security problems might show up or other problems. And these days there's a new tool developed as syscaller. It's also doing fuzzing. Support for that is not yet in the kernel, and the thing is still developed, but already it finds quite a few bugs. I think there were about 30 bugs in one of the latest 30 changes in one of the latest stable kernels that were fixed after syscaller found them. There's also continuous integration tools now running. There's a K-build test robot that if you send a patch to some mailing list, this robot watches that robot grabs the patch and compiles this and sends, if there are problems, it sends a mail to the mailing list, hey, your patch doesn't work or it doesn't compile, and so you get blamed for that actually in the open, so better prepare your patches and check if everything works. And there's actually the ARM guys from Leemhuis set up kernelci.org where kernels are constantly tested and booted in QEMU to see if everything works. In the news, everywhere there were a few voices that there were development problems like aging developers, lack of contributors, review stalls, and especially the discussion tone between the kernel developers. Some of you might have heard of Sarah Sharp or Matthew Garrett that said, hey, that's it's not. They complained how Linus and some of the other sometimes talk to each other and said that has to improve to get new kernel in. That's actually a quite complex topic. That's why I don't want to go into that here any closer. The short version is basically a lot of things are way better than 5 or 10 years ago. Actually, I noticed when I wrote that I'm actually looking at kernel development for 10 years now. When 10 years ago, it was really way more bad. So a lot of things are bad, are already improved. Sure, some things could be better, but that's always the case. It's maybe it's good enough already. Depends. I, for one, think in the past year, nothing too much out of the ordinary happened. Linus once said something really awful, but he didn't say that to a developer who was new on the list. He said that to some developer he already knew for years. So it's a bit like among friends. The tone is a bit rough sometimes there on the kernel mailing list. So that was part 2. I need to oil my voice again. Question? Yeah.
I have one question about the EBPF thing that you mentioned. Do you know if the EBPF thing is going to be developed, the kernel part and the user level part, more in sync than the original BPF code? Because in the past I've been bitten by some bugs in the kernel supporting features in BPF that BPF did not generate bytecode for. So it was kind of easy to get fixes in the kernel and complicated to get fixes in the user level parts.
Yeah, I've heard about it, but I actually can't answer that for sure. I think they wanted to make sure that it doesn't diverge too much, but it's also not just like a stable API. Sometimes you need to update both sides to one version.
But is it going to be a separate project, or is it the same?
Actually, it's some code to compile eBPF code is in LLVM these days. And if you're using it with perf or something, it's quite easy to compile. That's what I know. If you want to know more, there's Daniel Brockman. He's one of the main developers behind that. He gave a presentation past week on Thorsten about the eBPF and its features, mostly from the networking side. That might have some answers, and you can email him.
Thank you.
So, next up, wait a moment. Things in the works. So, what's coming in the next few months? Queibas isn't coming. I guess most of you have heard about that. that was abandoned. What was Queibas, for those that haven't heard about it, was a kernel-side replacement for the dbus daemon, so the thing that passes the dbus messages around on your system. And developers said, okay, no, we don't go that direction anymore there and start from scratch again, mostly. And now they are working on making a message bus that is more universal. So it can be used for dbus transfers, but it also can be used for other things. The thing is still under development, remains to be seen when we see it for the first time. ButterFS, also something I guess most of you have heard about. It is a file system. It was in the 2008 or 2009 considered the next generation Linux default file system. Back then it was said it needs some time to develop, but I guess nobody expected that 2016 it's still not really finished. And the thing is, these days you don't hear so much about it, and I think that's a good thing because developers are stabilizing ButterFS. They find, actually it's used in Facebook already because the main ButterFS developer works for Facebook these days. And they found a few bugs there and fixed them and made some features that were not completely finished yet, also worked on that. So stabilizing is what's now done there. Question that always comes up then, is it ready yet? And I think that's a question that basically is like asking, is the water safe to go in? If you think about it, the answer always depends on your abilities and your local conditions. Because if you're going to the sea and there's rough winds and tides or something, you might get dragged in, even if you're a really good swimmer. On the other hand, if you're a really bad swimmer, even in your local pond, you can drown. But as I said, Facebook uses this. SUSE also uses it by default on SUSE Linux Enterprise Server, and OpenSUSE also uses it. I myself also use it, but actually before traveling here, I saw that ButterFS filled my disk already, and I need to run a kind of defragmentation to get free space again to make ButterFS perform better. So that's something you need to learn. And so ButterFS is not that ready that you can simply use it. I'd say for now it's something if you're interested in it and want to use the features ButterFS offers, then learning that and dealing with those kind of problems that are still there might be worth it. But that's something you have to choose for yourself. Kernel live patching is something that was announced 2 years ago on this conference from the Red Hat sides. Actually, with different patch set back then, SUSE also did something to do live patches, so to fix security bugs in your Linux kernel without rebooting. And they SUSE and Red Hat merged their efforts. That's now in the kernel. It's called, as I said, Kernel live patching, KLP. The basic function got merged about a year ago, I think, and it allows to fix about 90% of the bugs that typically show up in the kernel. The Red Hat and SUSE solutions actually were able to fix 95% of the bugs. That's something the KLP developers work on, but there are some roadblocks that need to get solved. If you're interested in details, Google for compile stack validation. That's something you need to, the developers need to see where the currently running code is used and how to fix all the different places where it's running currently. Also, things in the work is even more improvements for network performance. There are so many things coming there. Actually, if you're interested in that, there's a talk about that on Sunday at 11:30. Kernel network stack changes at 100 gigabit speeds because their interrupts create so much overhead and memory allocations. The kernel needs to change to make that happening. Rich ACLs is an improved mechanism for access control list. It's possible to use to set up a more consistent and more flexible permissions, especially for ACLs, especially for NFS servers, and especially if you're running NFS v3 and v4 at the same time. I'm running out of time. That's because I'm getting quicker and quicker. I guess the AHCA for AMD I'm skipping. And the cluster support, maybe a few embedded developers are interested in this. The kernel isn't ready for 2038. That's similar to the problems we had when we switched to year 2000 a few years ago. It's only relevant for 32-bit applications. The kernel needs to get changed, and file system needs to get changed to store timestamps after year 2038. That's actually in the work, and LWN recently wrote that it might get finished this year. I guess that's possible. Maybe it takes a bit longer, and then it even takes a bit longer till userland is also migrated to handle everything, but we're getting there. Some of the BSD actually fixed that already 2 years ago, but it's easier for them for various reasons. Tinification is also something that's a few kernel developers look at now. It's like making the kernel a bit more smaller and reducing the overhead to make Linux suitable for Internet of Things devices. There were also some roadblocks where people wanted to reduce the network stack to the really basic functionality, and the network subsystem maintainer said no. That was already years ago. But over time, people arrange, and it's possible to make the kernel smaller and smaller to make it more interesting for Internet of Things devices, which actually become more powerful thanks to enhancement in processors. So it might be not that much of a problem. So Linux might be used there quite a lot. Kernel hardening is also something where a few people invest more time these days. They look at, for example, for the GR security patch set, which has a few security enhancements for the Linux kernel, and those developers look if they can get those features or some features like that into the kernel to make security, to improve the security from the basic for the standard mainline kernel. Container is something where not that much happening is in the kernel, but there are a few small changes to improve security and realize new features. Seegroups, for example, is one of the areas where a few enhancements are needed, and that's so a little bit is happening there. Android mainlining is also something that's now around for many years now, there where people try to get improvements that are part of the Android kernel get into the mainline kernel. The network socket destroy function I mentioned earlier is one of those features, but there are still a lot of things in the Android kernel that are not yet part of the mainline kernel. But slowly, if things are getting better, so maybe in if a year or two, it's really possible to run an Android device with a mainline kernel without any Android-specific patches. Realtime, for those of you that have been here in the earlier talk, that's also something where a lot of people are interested in to get deterministic behavior. The situation 1 year ago looked a bit sad because the developers that are mainly driving that stuff forward to get the real-time enhancement into the kernel needed funding. That situation actually is mostly solved. The Linux Foundation started a collaboration project last fall to get that running, and these days there are, I guess, at least five developers that are being paid to get the real-time stuff into the kernel. And actually, thanks to that, getting it into the KVM also, and then you can do real-time in VMs. That was actually in the talk that was in this room right before this. You can watch it on YouTube later if you're interested in that. That was part 3. getting closer to the end. Question?
How many slides are in your slide deck?
That question is actually asked in a few minutes. I have a few post slides. Is there another question? Was it too quick?
I like the format. It's good.
Okay.
How difficult is it to get from a kernel commit to a live patch?
How?
So when you extract the commit from the kernel gate, how difficult it is to get from there to a live patch for the kernel?
Actually,
Special skills to do?
yeah, you need to be a kernel developer and look what changes. Like if you're doing live patching, if the data structures change, you can't do live patching, for example.
You have to put a lot of attention into what's going on in there.
Yeah, actually, Red Hat and SUSE offer it as a service, because if you want to do it yourself, you have to be really skilled to do that.
All right, thanks.
So I guess I have a minute, maybe a few post slides. If you want to know more details, just Google for them, and there are more details about everything I talked in the web. If you don't find anything, just ask me. One thing I normally do on this talks is telling people to help testing the kernel. I'm skipping that because I'm doing a lightning talk today at 6:50 or something. It's I don't know which room. Just look it up in the schedule. I go a bit into that there. The other thing I wanted to ask you is give me feedback. I might do this again if you don't tell me how bad I was, and or if my English was that bad. And tell the organizers also on the webpage there's a feedback survey. So otherwise they might invite me again. And that's actually slide 185. That's it. And if there are other questions, simply grab me on the hallways or something. Enjoy the conference.
The presentation was great.
Do you like the format?
It was dynamic enough to keep me wake up.
Okay.
It's hard today. I must go for coffee.
Can I grab you one?
It's okay.
Okay. Actually.
Muss ich deinen Talk auf Video angucken?
Ach, das schafft manchmal voll oder was? Okay.
I really enjoyed the format because there's so much information you had to move quickly.
Okay.
So it was very good.
Sometimes I'm not sure because it's so much. I guess maybe I'm not.
If you put up all those bullet points, it would be like,
Yeah,
whoa.
yeah.
That way you can really keep, so very good format.
Okay. Thanks. So. Yeah.
I'll have to get